All right, today we're going to talk about our factoring polynomials using the GCF, or greatest common factor. So when you're factoring, that is the reverse of distributing. So it's the reverse of multiplying. So we can even factor monomials into a product of prime numbers and variables. And to factor means to write a polynomial as a product of two or more expressions. So to factor a GCF of two or more monomials, you need to first factor each monomial completely, use the lowest exponent of each base that the monomials have in common. So we're going to go through, I'll walk you through this. Oops, wrong page. Okay, here we go. So we're going to find the greatest common factor of each. So we're looking at the numbers 42 and 60. So one way to do this is for 42, list all the factors of 42. So 1 times 42 is 42, 2 times 21, 3 times 14, and 6 times 7. So those are all the factors of 42. And then we're going to list all the factors of 60. So 1 and 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. And we're going to go through and we're going to look, and we see that they both have 6 in common, and that's the greatest number they have in common. So the greatest common factor is 6. Now, you may have also remember, if you did this a while in elementary school or middle school, where you could go through and you can divide it, each term, let's say, by 2. So we get 21 and 30, and then divide by 3 because they have that in common, and we have 7 and 10. So multiply these two together, and then that is your GCF. So that's one way to do it. You also have, it's the ladder or birthday cake, whatever way method to do too. But basically you have to list the factors. All right, so now we're going to get into it where we have variables. So for this way, what you can do is we're just going to list the factors of 25 and x. So 1 times 25, and then 5 times 5, but we only write it once. And then don't forget x. All right, now we're going to do 36xy. So we've got 1 times 36, 2 times 18, 4 times 9, 6 times 6, and then x and y. So if you notice, out of all of these, the only thing they have in common is x. So your greatest common factor is x. All right, so I want you to try this one. It is a little tricky because you do actually have 3 variables to look at. So go ahead, try that one, and we're going to do this one. So if you get stuck, watch this example and then go back. All right, so now I have 3 different things to look at. So first off, with 15, 3, and 6, the greatest common factor they have is 3, because this is 5 times 3, 3 times 1, 2 times 3. All right, so for 15, 3, and 6, the greatest common factor is 3. So we're going to bring this down here. Now, for your variables, this is where it gets tricky. For a to the 4th power, I have 4 a's, because remember, you're multiplying all those. And then for b to the 4th power, I've got 4 b's. And then we're going to go a to the 4th power, b to the 5th power, a to the 3rd power, and b to the 6th power. And here we have to do the least amount of variables. So the smallest number of variables we have is a to the 3rd power, because this doesn't have any extras. So you can only take out 3 from each group. And then here, if you notice, the smallest group is 4, so I can only take 4 b's out. So now put them all together and you have 3, a to the 3rd, b to the 4th is the greatest common factor. All right. So for this one, what we're going to do is we're going to factor out a GCF. So to multiply a monomial by a polynomial, you distribute. So remember, we would just talked about how we're multiplying, but to factor out, you undistribute or divide your GCF. So the GCF is the greatest common factor. So let's look at this first one. Now I'm looking at 5x plus 15. Their GCF is 5. So I'm going to divide each term by 5. Whatever you divide by is going outside the parentheses. So when I divide 5x by 5, what's left over is x. That goes inside the parentheses. And then now we're going to take 15 divided by 5, which is 3. So 5, this is your GCF, which is outside, and then everything that's left over goes inside the parenthesis. But the final, this is factored. All right, I want you to try this one. Now let's look at number 3. For number 3, I've got 2 A's here, and I only have 1 A here, so I know I can only take 1 A. I've got 1B here, so that we can take a B. So our greatest common factor is A times B, or AB. So we're going to divide each term by AB. So that's what's going outside the parentheses, and then everything that's inside is what's left over. So remember, if you were to have 2 minus 1, you only have 1 A left over, so we took 1 out. Now here, these are both B over B. That simplifies to 1, so we don't have anything else left here. But here, your A's cancel out, because that's to the first power. Your B's cancel out, and I'm only left with 2. So this is the leftover, and then this is the final factored form. All right, I want you to try that one. It has 3 terms, but you're still doing the same thing. All right, now let's look at number 5. And here, I've got 14 and 2. Well, the greatest common factor of that is 2. And then for your x's, I have x squared and x squared. So we can factor out an x squared there. And for here, I've got y to the 4th, y to the 1st. Well, that's the smallest, so we can only use that one because we can't take anything if it's not there. So we're going to divide each term by 2x squared y. And then we're going to use our quotient rule. So remember, 14 over 2 equals 7. And then that simplifies. And then here we have 4 minus 1, which is 3. So 7y to the 3rd. And then 2 over 2 equals 1. And that cancels out. And then that cancels out. So since everything canceled out, you still need something to hold its place. So that's why we're putting a 1 there. So remember, whatever you divide by goes outside. Whatever's left over stays inside. All right, I want you to go ahead and try all 3 of these. And now, there's a couple things. If your leading term or your first term is negative, your GCF should be negative because you want to factor out that negative. All right, so let's look here. I've got, a negative 3 and a positive 12. So the greatest common factor is going to be negative 3. And then for your x's, I have x squared, x to the 1st. So the smallest we can do is x to the 1st. And I've got y to the 1st, y to the 3rd. So the smallest exponent is what you take out. And then for z, I have to the 4th and to the 3rd. So the smallest is to the 3rd. So your GCF is here, and this is what you're going to divide each term by. So when we divide by this, remember that's what goes outside, and then whatever is left over goes inside. Now remember, I've got a negative here and a negative here. Well, since we divided the negative 3 over negative 3, that gives us a positive 1. And then 2 minus 1 gives us 1. Our y cancels out to, or simplifies to give you 1. And then 4 minus 3 is 1. Now, again, we have positive 12 over negative 3, which gives you negative 4. Your x's cancel out. Your y is 3 minus 1, which is 2, and your z's cancel out. So this is your final factored form. All right, go ahead, try that one. And then that was a pretty short one for factoring out GCFs. But it's a very important one because our next few units are going to be dependent on factoring.